G'day lads, in this video I'll show you how to build an NFL model in Excel to calculate odds for the money line, spread and total points markets for daily analysis. Now lads, this video is quite long. If you want to save time or your version of Excel doesn't support the video's array functions, then make sure you click the first link in the description below to download the model and become a member of Excel Lads on Patreon. Not only can you download a legacy version of this file that works for older versions of Excel, but with your membership, you can download the Excel Lads NBA, NHL, MLB, and soccer models, as well as in-depth member-only articles. So before the video, I encourage you all to sign up and join hundreds of other lads to become part of the fastest growing sports modeling community on YouTube. So lads, before I import all the data I need for this model, I'm going to start with a blank spreadsheet and create 4 new worksheets called 2023 NFL data, 2024 NFL data, NFL standings, and fixtures data. Now what I'm going to do is use a Power Query to bring in the stats from the official NFL website as well as Pro Football Reference in these 4 worksheets. Now I haven't shown you how to do this in this video because the process is different depending on your version of Excel as well as your computer. Now starting in column A is the 2023 NFL team scoring data set. Beside it in column H is the 2023 rushing defense data set. In column U is the NFL team receiving defense stats. And then in column AI, the field goals made stats. Now all 4 of these data sets are from the NFL official website and the links to that are in the description below. This model is going to be for the 2024 NFL season. So I need the previous year's data, 2023, as well as the current year's data. And if I go into the 2024 NFL data worksheet now, you'll see the data sets brought in by the 4 Power Queries are exactly the same. They're formatted the same, they're in the same columns, and that's important for the later formulas where we need to change 2023 to 2024 when considering the newer data in our model. Now lads, in the third worksheet, NFL standings, I've got the standings for the current season in columns A to Q. And again, this is from the NFL official website with the link in the description. In column A is the list of teams, and then beside that is the wins, draws, and losses they've had that year. And beside that is the previous year's standings, 2023, again from the NFL official website, formatted exactly the same through the Power Query. And you'll notice sometimes there's a few funny symbols next to a team's name indicating if they made the playoffs that year. Later on in the video, I'll come up with a formula to keep it consistent with the 2024 official standings. And in our last worksheet is the fixtures data. This is actually from the website Pro Football Reference. Again, the link is in the description to get that data set. And here it's just all the teams, all the games in the season, the results if they've been played, and the time and date for the games that haven't been played. Later on in the video, we'll create a box in the dashboard we'll build whereby you can put in a date range and then it will return all the fixtures in that range. Using this data, lads, I need to create attack and defense ratings to gauge how strong each team is. And to do that, I need to create a new worksheet called Team Ratings. In A1, put the text team. Beside that, 2023 games, 2023 passing touchdowns, 2023 passing touchdowns against or conceded, 2023 average rushing touchdowns, 2023 rushing touchdowns against, and then in column G, 2023 field goals made. Now I'll copy and paste all of that beside it in column H to M and then replace 2023 with 2024. So I've got those 7 stats for each year and I need to pull them in for each team. Firstly, I need to grab the name of each team in column A using the unique function. It's going to be equals unique. I'll go back into the 2023 NFL data worksheet and then from A3 to A66, that'll grab every single unique name there. Of course, that'll bring in the 32 NFL teams. Now, beside that, in cell B2, I need to bring in the amount of games the Lions played in the 2023 NFL season. And to do that, I'm going to use the sum of 3 index functions, which will find the amount of wins the Lions had, the amount of ties they had, and the amount of losses they had in that season using the 2023 NFL data worksheet. So the first index function is equals index will go into NFL standings, and then the array is going to be U3, and instead of going down to U66, I'll just simplify it just in case the Power Query ever expands the range of data and go down to U200. Now, absolute reference that by putting in $ in front of both the row and column. Now, comma, match, the lookup value is A2, comma, then I'm going to use an if error function, and in that is text before. The text is going to be NFL standings T3 to T200. That is the text of all the teams, and I'll make sure to put a $ in front of both the row and column again, so that when I drag it down for the teams below the lines, the range doesn't shift. And the delimiter is speech mark, space, then speech mark. It's important you leave a space between the speech marks here. Close the bracket, comma. The value, if there's an error, is just going to be the range T3 to T200 again, so you can copy and paste that in. Close the bracket, comma, the match type has to be exact, so put a 0 there. Close the bracket, subtract 1 for the row number, and then close the bracket. Now it's time to add the second index function, and here it's going to be index, open bracket, going back into the NFL standings. I'm summing the amount of losses the Lions had. That's in column V, V3 to V200. Now the row number is going to be a match function. So match, the lookup value is A2, the team in question, the Lions. The lookup array is again an text before function wrapped in an if error function. So the value is text before, the text is NFL standings T3 to T200 again, and the delimiter is again speech mark, space, speech mark, close the bracket, comma, the value if error is T3 to T200 again. Close the bracket, comma, 0, close the bracket, -1 for the row number, close the bracket, and then finally we need to add the amount of ties the Lions may have gotten in the 2023 season, and that's one final index function. This time the array will be W3 to W200. The ties are in column W for the 2023 NFL standings. The row number is the same thing as the formula before. It's just a match function with a lookup value of A2. The lookup array is a text before function within an if error function. And of course the text is T3 to T200 again, paste that in. The delimiter is the same, speech mark, space, speech mark, close the bracket, value if error is T3 to T200, close the bracket, I want an exact match, 0, close the bracket, -1 for the row number, close the bracket. Now when I press enter, the Lions have played 17 games in 2023, which is correct. And when I double click the bottom right hand corner of the cell, which drags the formula down to row 33, I get 17 games for each team. This model only considers games in the regular season, so this is true for every team. Now in column C, I need to pull in the passing touchdowns the Lions scored in 2023, and this formula is much easier. It's just an X lookup function, which looks up A2, the Lions. The lookup array is in the 2023 NFL data worksheet. We're looking up the Lions within the list of teams from A3 to A200 in the NFL team scoring data set. And then we want to return the number of touchdowns they've scored, and that's in column C. The receiving touchdowns, C3 to C200. So now I'll absolute reference all that by selecting the last two arguments, pressing the shortcut command T, which puts a $ in front of both the column and row in the formulas, and then dragging that down to row 33 so that I get the passing touchdowns for every team. And then the Lions have 30 receiving touchdowns or passing touchdowns in the 2023 NFL dataset, which appears in C2, so the formula is correct. Now beside it in cell D2, I've got to get the number of passing touchdowns they've conceded. And so again, I'm looking up A2. This time I'm looking A2 up in the list of teams from U3 to U200, and then returning column Y, Y3 to Y200. So I can drag that down to row 33 now. The Lions scored 30 touchdowns, but conceded 28 passing touchdowns in 2023. In E2, again, X lookup, I'm looking at A2 within the list of teams from A3 to A200, and then returning column B, the rushing touchdowns they've scored that year. So B3 to B200, again, absolute reference that. So when I drag the formula down for each row, the ranges don't shift, and I can get the number of rushing touchdowns the Lions have conceded in 2023 as well by looking at A2 within the array H3 to H200. That's the NFL team rushing defense data set from the NFL official website, and then returning the column L3 to L200. So I'll absolute reference that again, press enter, and then I've got the rushing touchdown against stats in column F. Now for the field goals made, that's another simple X lookup function. I'm looking up A2 within the data set, 2023 field goals made, and the lookup array is going to be AI3 to AI200, with the return array being the field goals made in the column next to it, AJ3 to AJ200. Put a $sign in front of both the row and column, and then drag that down to row 33 for every team. Now it's a bit simpler to find the stats for the 2024 season because we've formatted the 2023 NFL data and the 2024 NFL data worksheets the same. So what I'm going to do is copy the text of the function in B2 into the cell H2, and then what I've got to change here are a few cells. So firstly, I've got to change all the U's with B's. So every time I see U in that first bit of the function there, I've got to change it with B. Then I've got to replace every instance of T with A, because the column located in T is now located in A for the 2024 standings. Now I've got to replace V with C, and then finally W with D for the last index function. When I press enter on that, I get 2 games for the Lions, and every other team has played 2 games because I'm doing this model at the completion of week 2 in the 2024 NFL season. Now, just double checking and showing you how I'm replacing all the columns in the 2023 NFL standings to 2024. For example, column T for the list of teams goes to column A for the list of teams in the 2024 season. Now for the average passing touchdowns and everything to the right of that, all I've got to do is copy and paste the corresponding formula for the 2023 same stat, and then replace 2023 NFL data with 2024 NFL data. I don't have to change any columns, I don't have to change any rows. All I have to do is replace 2023 with 2024 because they're formatted the same in the 2024 and 2023 NFL data worksheets. So I'm doing that for column L now. And then finally, I do it for column M. 2023 NFL data goes to 2024 NFL data. When I copy that down to row 33, I've now got all the stats I need to make attack and defense ratings for each stat. Before I do that though, I'm going to go down to cell A35 and type in the text average. Here I'm going to find the average for all the stats above, and to do that, it's just a simple average function. In column B, it's equals average B2 to B33. Close the bracket there, press enter, and then I'm going to drag this formula across to column M, or cell M35. Once you've done that and get averages for all the stats above, I can reduce that to 2 decimal places to make it a bit neater. And then I can go back up to row 1, and from cells N1 to R1, I'm going to put in the following text. It's going to be passing touchdown ATT, or attacking rating, passing touchdown defensive rating, rushing touchdown attacking rating, rushing touchdown defensive rating, and field goal average. So this gets the attacking and defensive rating for each team for both the 2 stats of passing and rushing touchdowns, as well as grabbing their average field goals made per game. Now, an attacking rating is how good a team is relative to the league average. And in cell N2, you're going to put the formula equals if error, 2 opening brackets, max function, the maximum between 0 and 12 minus $H2 2024 games, divided by 12, close bracket, multiplied by, open bracket, C2, that's the passing touchdowns in 2023, divided by $B2. Close that bracket there, then divide that by open bracket C $35 divided by $B $35. That's the average number of games each team has played in 2023. Close the bracket, comma, 0, close the bracket, plus another if error function. This is going to work with the 2024 stats now. So 2 opening brackets, the minimum function between 12 and $H2, open bracket, close bracket rather, divided by 12, close bracket, multiplied by, open bracket, I2, the passing touchdowns the Lions have scored so far this season, divided by H2, the number of games. Close the bracket and then divide that by C35, $ in front of the passing touchdowns figure there, divided by B35, the number of games in 2023. Close the bracket, comma, 0, close the bracket. And what I can do is drag this formula down and across to cell Q33 and get attack and defense ratings for all the teams for all 4 of these stats. Now, with those min and max functions, these ratings are generated over a 12-game trailing window. So, for example, if a team has played 6 games so far in the 2024 season, half of their stats will be based on their performance in 2024. The other half will be based on their 2023 performance. Now, to get a team's average field goals in cell R2, put the formula equals if error, 2 opening brackets, max between 0 and 12 minus $H2. Divide that by 12, close the bracket, multiply by G2. And G2 is the field goals made in 2023, divided by $B2, the 2023 games the Lions have played. Close the bracket, comma, 0, close the bracket, plus if error. And this second if error function will be based on the team's average number of field goals in 2024. The current season, 2 opening brackets, min between 12 and H2, divide that by 12, close the bracket, multiply that by $M2, the field goals made in the current season, 2024 in this model, divided by $H2, close the bracket, comma, 0, close the bracket, and then the Lions have scored 1.34 field goals on average in their trailing 12-game window. So I can drag that down to cell 33, and I've got to get an average for columns N to Q here. It's not the average attack and defense rating, which will be 1, but rather the average passing touchdowns per game. And to do that, I've got to go equals if error, 3 opening brackets, and of course this is over the 12-game trailing window, max function, open bracket, 0, the max between 0 and 12 minus H2, divide that by 12, close the bracket, then multiply that by C35, the average passing touchdowns for each team over the course of the 2023 season, divide that by $B$35, the average number of games a team has played per season in 2023, comma, 0, close the bracket, and then I'm going to add an if error function, again, 3 opening brackets, and yet again, this is for the 2024 side of things now, min, open bracket 12, comma, H2, close the bracket there, divide by 12 for that 12-game trailing window, multiply that by I35, close the bracket, and then finally divide by H35, which is the 2024 average games per team. Comma, 0, close the bracket, press enter, and then you can drag that cell across to Q35. Now, you'll get 2 of the same values here. N35 should equal O35 because we're finding the same thing, average passing touchdowns, 1.33 in this case over the trailing 12-game window. And then for columns P and Q, the average rushing touchdowns have to be the same, 0.87. And now, lads, we've captured the significant methods of scoring in an NFL match, the passing and rushing touchdowns along with field goals. We've also, however, got to consider the less significant methods of scoring, such as interception touchdowns, safeties, conversions, 2-pointers. And to do that in this model, I'm going to standardize them because these methods of scoring are either unlikely to occur, or when they do occur, there's not too many differences between teams in how they're scored. So I'm going to create a new worksheet called miscellaneous stats, and in here I'm going to import data that will allow the model to standardize each stat for each team. So lads, right now I'm on the Pro Football Reference website and I'm on the 2023 NFL season under the scoring offense table. Now this link is in the description below. I'm going to get the table as a CSV and then I'm going to copy and paste this into Excel. So copy that and then I'll go back into Excel now, and then in cell A1 of the miscellaneous stats worksheet I just did, I'm going to copy and paste this whole thing in, go to the data tab, go to text to columns, press that, make sure delimited is selected, next, and then you've got to make sure that comma is selected. So I'll select comma and then I'll press finish, and then all the stats will be transformed into a nice and neat table like this. Below the data set, I'm going to go down to cell B38 and then start typing in some text. So first I'll start with 2023 average fumble touchdowns. Below that, average interception touchdowns, return/other touchdowns, average safeties per game, extra point 1 percentage, extra point 2 percentage, extra point success rate, 2-point success rate, and the home advantage. So starting in cell C38, I'm going to get the formula to get a team's average fumbles touchdowns per game in 2023, and that's the sum of H2 to H33, all of the teams. Close that, divided by 32, the number of teams, divide that by 17, the number of weeks, and so we get a figure of about 0.03, meaning on average in every game in the 2023 NFL season, there were 0.03 touchdowns scored by way of fumbles. So for the next row, it's going to be open bracket, the sum of I2 to I33, close that, and again, divide by 32 for the teams, divide by 17 for the games played. And so there was slightly more interception touchdowns scored, that's 0.08 per game. Now for other and return touchdowns, it's the sum of J2 to J33, comma, the other touchdowns, plus the kick return and punt return touchdowns from F2 to G33. Divide that by 32 and then divide by 17 again. Press enter. And then this is about 0.03 as well. So pretty much the same as the fumble touchdowns. To get the average number of safeties per game, I'm just going to sum all the safeties scored by teams in the 2023 season, divide by the number of teams, and then divide by the number of games played so that I can get an average figure per game. And again, that's about 0.03. Now, extra point 1 percentage, whenever a team scores a touchdown, they have a choice to either go for 1 point, a conversion, or a 2-pointer. This cell is the percentage of times they choose to go for an extra point, just 1 point. So that's P2 to P33 divided by the sum of, open bracket, we're going back up to the same range, extra point attempts, P2 to P33, plus 2-point attempts. And that's the sum of M2 to M33. Close the bracket twice and then press enter. Once you do that, you can see in the 2023 NFL season, a team opted to take the 1-point conversion 90.2% of the time. And then in cell C43, 1 minus that equals about 9.8%, meaning a team chose to attempt a 2-point conversion 9.8% of the time. So we can reduce rows 38 to 41 to 2 decimal places and then put rows 42 to 45 as a percentage to 2 decimal places. Now we need the success rate of a team kicking a conversion for 1 point. And that's going to be the conversions made divided by the conversions attempted. So that's the sum of O2 to O33 divided by the sum of extra points attempted from P2 to P33. Close the bracket there, press enter, and then I'll change that to a percentage, and we can see 95.89% of the time that conversion is successful. Now for the 2-point conversion, that'll obviously be a lower conversion rate, I assume. And to find that, it's the sum of the 2-pointers made, the sum of L2 to L33 divided by the 2-pointers attempted. So that's the sum of M2 to M33. And converting to a percentage, that is lower at 55.12%. Now for the home advantage, historically, that's been about 10%. So I'll leave cell C46 as 10%. Now that we've got the average rate of scoring all of the above stats, I can create the worksheet named dashboard, and in here I'm going to be able to select 2 teams and then find their expected points as well as their win probability. So lads, in the dashboard worksheet, I'm going to merge and center some cells now. So from A1 to C2, I'm going to change the text size to 24 and put the text away below that home. Next to these two cells, I've got to be able to create a drop-down list to select the away and home team for a matchup. So I'm going to merge and send the cells D1 and H2 and copy and paste that below. I'm also going to merge and send the cells I1 and J2 along with K1 and L2 and make sure that we put borders in the middle of them. So in cells D1 and D3, I've got to have two teams next to it in columns I and J, eventually their expected score for that matchup, and then to the right in cells K1 and K3, their win probability. Now to make a drop-down list, select cells D1 and D3, go into the data tab, data validation, allow a list, and then the source for that list is going to be equals, and then the list of teams in team ratings. So go into team ratings, and then it's going to be A2 to A33, the Lions to the Jets, press OK. And then once you do that, I can go into cell D1, have a scroll through the list and select a team. I know coming up in week 3, the Giants are versing the Browns. So I'm going to select the Giants as the away team and the home team as the Browns. Now in cell I1, I've got to come up with a formula to get the Giants' expected points against the Browns and have that change for whoever they're versing. If they're versing a stronger team, perhaps the Giants' expected points will decrease. Now lads, we'll use a let function to be able to do this. This will be fairly long, but hopefully very logical. The first name is away underscore advantage, and this will be a disadvantage for the Giants. So that's equal to 1 divided by the square root of 1 plus the home advantage in cell C46 of the miscellaneous stats worksheet. Close the bracket there. My next name is X underscore touchdowns, the expected touchdowns the Giants are expected to score. So that's equal to the away underscore advantage we just defined, multiplied by, open bracket, X lookup. I'm going to look up D1, the Giants, within the array A2 to A33 of the team ratings. So that's the list of teams within the first column of the team's rating worksheet. A2 to A33, make sure you absolute reference that by putting a $ in front of both the column and row. And then I'm going to return column N2 to N33. And that is the passing touchdown attack rating for the away team. So absolute reference that as well. Now to find the expected passing touchdowns of the away team, you're going to multiply their attack rating for passing touchdowns, multiply that by the Browns' passing touchdowns defense rating, and then multiply that by the league average passing touchdowns per game. So to find the defense rating for the Browns, it's another XLOOKUP function, and I'll paste in the previous XLOOKUP function. I'm still looking them up, the Browns, the team, in the range A2 to A33, but instead the range for the defense ratings is in column O, O2 to O33. Now the league average passing touchdowns per game is in cell N35 of the team's ratings worksheet. And so now I'm going to add on the expected rushing touchdowns the Giants are expected to score. And that's the same formula. So it's looking up D1 within the list of teams, A2 to A33, and then returning the Giants' attacking rating for rushing touchdowns. That's in column P. Multiplying that by the Browns' defensive rating in terms of rushing touchdowns, and that's in column Q after looking the Browns up in the A2 to A33 range, and then of course multiplying by the league average rushing touchdowns per game. That's back in team ratings, and we'll go in there, and then that's equal to 0.87 or P35 for that trailing 12-game window we calculated earlier. Now I'm going to add the sum of all the other ways the Giants could score a touchdown, and that's standardized for every team. That's just C38 to C40. The sum of C38 to C40, absolute reference that. Close the bracket twice. And then so now we've got our expected touchdowns figure. If I go comma, expected touchdowns, the name we just defined, and then close the bracket, the last argument of a let function is whatever we're returning. So for this match, the Giants are expected to score 1.43 touchdowns against the Browns, and we can keep continuing with the let function to calculate the probabilities of them scoring other ways. Now the next name in the formula is going to be sim underscore safeties, where I'm simulating the number of safeties Giants score in this game using the binomial inverse function. I'm going to do 10,000 trials with a probability of success equal to, open bracket, the away advantage multiplied by cell C41 in the miscellaneous stats worksheet. That's the average safeties per game. Absolute reference that. Close the bracket twice, divide by the number of trials, which is equal to 10,000, and then the argument for alpha is going to be equal to the rand function, open bracket, close bracket. This generates a random decimal from 0 to 1 to randomize the function. So the next name is going to be sim underscore touchdowns, where I'm going to use the expected touchdowns figure to get a simulated result using the binomial distribution. So again, binom.imv, 10,000 trials, probability of success is equal to expected touchdowns divided by 10,000, and then to randomize this, use the rand function as the alpha. Close the bracket there, comma, the next name is going to be simulated touchdowns, so we can test it. Again, the last argument of a let function is what it produces. In the first one, 4 touchdowns, next one 0, now 2, 1, and if I hold down the backspace button to refresh all those trials, the number of touchdowns the Giants score in a simulated match changes. So we can continue with the let function after testing that out, and the next name is going to be sim underscore extra underscore point underscore attempt. And here, using the simulated touchdowns the Giants will score in a simulated game, we're going to simulate how many times they take the 1-point conversion option. So the number of trials is equal to the simulated touchdowns, and out of those, we know a team takes the 1-point option about 90% of the time. We calculated that in cell C42 of the miscellaneous stats worksheet. So randomize that for the alpha argument, comma, then for the sim 2PA name, the simulated 2 points attempts, that's just going to be equal to the simulated touchdowns minus the simulated extra point attempts we just wrote down in the formula. And that's because if a team doesn't attempt a 1-pointer, they're going to attempt a 2-point conversion. Now, for the simulated number of extra points they get, we're going to use the sim extra point attempt name in the binomial inverse function again. So the number of trials is going to be how many times they go for that extra point, sim underscore extra underscore point underscore attempt, that's a mouthful, comma, the probability of success is equal to cell C44, they'll convert it about 95.8 of the time, and the rand function at the end to randomize it. And same thing for the simulated 2-pointers made, the number of trials or the number of times they take it is equal to the sim underscore 2PA argument. The probability of success is about 55% in cell C45, and then the alpha argument is randomized again with that rand function. Close the bracket. Our next name is the simulated field goals. Now to do this, we're going to grab a team's expected field goals and then put it in the binomial inverse function. So 10,000 trials and the probability of success is equal to away advantage multiplied by an XLOOKUP function, which will grab a team's average field goals in that 12-game trailing window. So XLOOKUP, open the bracket. I want to look up the Giants in D1 within that A2 to A33 team ratings range. So I can grab Giants out of that list of teams. And then after that, match it to the field goals column, which if you scroll across to the right in the team ratings worksheet should be in column R. So from R2 to R33. And there it is. Make sure you absolute reference this. So there's a $sign in front of both the column and row. On Mac, the shortcut for this is Command T. Now you want to close that bracket twice. The probability is divided by 10,000, comma, rand, open bracket, close bracket, comma. Now the next name is simulated underscore score. And here we're going to get a simulated score by adding up all the simulated methods of scoring. So that's going to be simulated touchdowns multiplied by 6 because the touchdown is worth 6 points, plus the simulated extra points. That's worth 1 each, so no multiplication there. Plus the simulated 2-pointers made multiplied by 2, plus the simulated safeties times 2, plus the simulated field goals multiplied by 3. Now, once you've done that, comma, we can work out the simulated score for a single simulation by putting simulated score at the end. And for this one, it's 0. So the Giants failed to score a single point all game. Now it's 6, now it's 17. And then with more simulations, that simulated score changes. Now there's one more name I want to put in this massive let function, and that's going to be the expected score. And rather than the sum of all the simulated methods of scoring, the expected score is the sum of every single expected value method of scoring. So it's taking the expected value of touchdowns, how many touchdowns the Giants are expected to score, multiplied by 6, plus the expected number of extra points they're supposed to convert, and that's equal to the number of touchdowns they're expected to get, multiplied by the number of times they choose the one-pointer option, multiplied by how many times they actually convert that, which is 95%, miscellaneous stats C44, plus the expected touchdowns multiplied by the extra point 2% in cell C43, multiplied by cell C45. This is the expected number of 2-point conversions the Giants are supposed to get, and then multiply that by 2. And then we're going to add the expected number of safeties, and that's equal to away underscore advantage, which we defined right at the beginning of the formula, multiplied by C41, the average safeties per game. Multiply that by 2 because safeties are worth 2 points each. And then lastly, we've got to get the expected number of field goals, and that's simply the away advantage multiplied by the average number of field goals the Giants have gotten in that 12-game trailing window. And to do that, I'm going to use an XLOOKUP function to look up Giants in the list of teams. That's in A2 to A33. And then just as we did before, I'm matching the row where the Giants are in the A2 to A33 range with the return array in R2 to R33 in order to pull in their field goal average. Make sure to absolute reference that by putting a $ in front of both the column and row. Once you do that, you're then going to close the bracket, multiply that by 3, field goals are worth 3 points, and finish off the let function with the expected underscore score command. And in this match against the Browns, the Giants are expected to score 13.64 points, which is a low total, and it probably means they're going to be the underdogs in this match. Now, in order to get the Browns' expected score, I'm going to copy this entire formula, the entire text of the formula, into cell I3. And then I've got to change a couple things. First of all, I've got to change away advantage to home advantage. Change the text there and get rid of the 1 divided by. The home advantage just becomes the square root of 1 plus the home advantage. Now I've got to change every instance of away advantage in the whole let function to home advantage. So I'll do that now. Home advantage, that's in the simulated safeties bit. Simulated field goals, you've got to change it to home advantage. In the expected points, name home advantage as well. I'm not done yet though. I've got to change every instance of D1 to D3 because now I'm looking for the Browns instead of the Giants in D1. I've also got to change D1 to D3 over here. Do it twice more in the simulated field goals name as well as in the expected score name. Press enter and then you'll get the expected points for the home side. In this matchup, the Browns, and they're the favorites with 24.78 points to the Giants 13.64. Now lads, these expected points figures will change depending on what teams you choose. So after I reduce it to 2 decimal points apiece, I'm going to have a play around with the teams and see how it affects the results. So if I change the Giants to perhaps a stronger team, for example, the 49ers, then they become the favorites, 26 points to the Browns 20. But if I change it back to the Giants, then not only does the expected scoreline in I1 change, but also the home sides in I3, that changes as well. We're able to simulate an entire game now, but if that game goes to overtime, we've got nothing yet to separate the two teams. So what we've got to do is make a new sheet called simulations, and in cell J21 put equals B1, and beside it in cell K21 put equals C1 for the home side. And then below this in row 22, I'm going to grab each side's simulated score. So that's normal or regular time in an NFL match. And to do that for the Giants, copy and paste the formula text from the expected score in the dashboard worksheet. But what I've got to do here is change every instance of D1 to dashboard D1. Because it's in a different worksheet now, I need dashboard at the front of the cell so that the formula knows what D1 we're talking about. Also, if there's a D3, change that to dashboard D3. There's only about 5 or 6 instances of it, which I've done here. Now when I press enter, I get the expected score of the Giants. However, I want the simulated score, and I'll change the last name of the let function to simulated score once I do the same thing for the Browns. So beside it, get the formula in I3 off the dashboard worksheet, copy and paste the formula text into cell K22, and then change every instance of D3 to dashboard D3, and of course every instance of D1 to dashboard D1. Again, there should be about 5 or 6 of these. Pretty easy to spot considering that the D1 and D3 should have color in them. And then we've got the expected score for the two teams now. I'm going to change it to the simulated score, which simulates 4 15-minute quarters. But of course, there's a slight chance that these two simulated scores will be equal after 60 minutes. And in an NFL match, that means it goes to overtime. So what we've got to do in this worksheet is find a formula to separate the two teams in overtime, and then simulate that 5,000 times to get a distribution of the results, which will help in finding probabilities for the money line, spread, and total points markets. Now in this model, I want to simplify overtime and give each team 3 drives to score. Now, to do this, I need to know the probability of every drive and its outcome. So to do that, I'm going to go to the website StatHead Football. This link is in the description below. Go to the drive finder, go to the 2023 or the previous season stats, press enter on that, and then for every drive in the NFL that year, it gives you the outcome and the likelihood of that happening. So I'm going to copy and paste that into cell J1 of the simulations worksheet and then summarize it in columns N, O, and P. So a punt has approximately a 40% chance of happening at the end of every drive, a touchdown 25%, field goal 15%, lost ball I've simplified to 19.75%, and a safety 0.25%. Now what I'm going to do, as I said earlier, is give each team 3 drives, and according to the rules of NFL overtime, the result of each drive will correspond with the probability table above in columns N, O, and P. Now, starting in cell J24 and going to the right, put the following column names: drive number, team, outcome, points, lead, points accumulated, and drive status or status after drive. Now, after you put them in bold, in cell J25 and below, put the numbers 1, 2, 3, 4, 5, and 6, as each team in this simplified model will have 3 drives at the maximum. Now, starting in cell K25, I've got to simulate which team starts with the ball first. And to do that, it's a 50-50 toss-up, equals if a random decimal is over 0.5, then return J21, the Giants. If not, return K21, the Browns. This gives each team exactly 50% of receiving the ball first. Now below that in cell K26, I've got to put in another formula. That's going to be another if function, equals if K25 equals cell J21. Make sure you put a $ in front of both the column J and the row 21. Then return cell K21. If not, return cell J21, the Giants. Now, when I close that formula and press enter, then drag that down to row 30 for the 6th drive, I can see that if the Giants begin with the ball, the Browns follow, then it goes Giants, Browns, Giants, Browns. On the other hand, if the Browns start, the Giants follow. So now in column L, I need to simulate an outcome for the Browns' first drive, all the way through to possibly the 6th drive of overtime where the Giants have the ball. So the formula for that is going to be an X lookup function, where the lookup value is a rand decimal, 0 to 1 multiplied by 100, and then I'm looking that random number up in the lookup array 05 to 09, the cumulative chance column, and then returning the outcome from range N5 to N9, 2 commas, and then I want an exact match or next larger item. So for the match mode, put 1, close the bracket, press enter, and then for the Giants' first drive, I get the outcome of a field goal. When I drag that down to row 30, you can see all the drives have been simulated. Of course, they may not be the same every single time. Now, for the points, I'm going to look up the outcome in cell L25, look that up in the outcome column, N5 to N9, and then return their corresponding points in column P. That's P5 to P9. Simple XLOOKUP function. Of course, a lost ball results in the Browns scoring 0 points. Drag that down to row 30. Now in column N and in cell N25, I've got to calculate the lead of the Browns after that specific drive. So for the first drive here, they've got a lead of 0. To do that, I've got to use a SUMIF function. So the range here will be K25 to K25. Make sure you fix the first part of the range though, putting a $ in front of both the K and the 25. Comma, criteria is K25, the team. The sum range is M25 to M25. Fix that first M25, close the bracket, and then subtract the SUMIF function where the range is K25 fixed to K25, so that when I drag it down, it goes K25 to K26 to 27 to 28, depending on what row you're in. And then for the criteria, it's going to be if K25 equals J21, the Giants, then return K21, if not return J21. Close the bracket there. The sum range is going to be M25 fixed to M25 again. Close the bracket there. You can press enter on that, and in this simulation, the Giants have a lead of 6 after scoring a touchdown in their first drive. And in this rare one, no team scored. They punted every single time, so there was no lead throughout overtime. In this one, the Giants punt after the Browns score a touchdown, so their lead as of that moment is -6. Of course, though, in NFL overtime, once a team scores a touchdown, the game's over. In cell O25, calculate the points accumulated using another SUMIF function. K25 fixed to K25. The criteria is K25. The sum range is M25 to M25 again, fixing the first bit. Close the bracket. Then I'm going to add an XLOOKUP function where my lookup value is K25. My lookup array is J21 to K21, absolute reference that range. And then I'll return the normal time or regular time score below that in cells J22 to K22. Close the bracket, press enter, and so the Browns score a touchdown in their first drive of overtime. That 6 points is added to their regular time score of 33 to get them a points accumulated figure of 39. Drag that down to row 30, and then I've got to get a formula for the status after the drive in question. Here, the drive number 1. So if a team scores a touchdown first, the game is automatically over. However, in the first drive, if all they kick is a field goal, then the team with the second drive has an opportunity to tie that or beat that and end the game with a touchdown. So if N25 equals 6, which is a touchdown, return no. If not, return yes. So here, the game is still going on because the Browns lost the ball in their first simulated drive. So the game continues. Now, in cell P26, put the function equals if P25 equals no, then return no. Of course, this has got to be text in speech marks. If that's not the case, then return an if function where if N26 is not equal to 0, denoted by the less than and greater than signs together, then return no. If not, return yes. 2 closing brackets, and here what's happened is the Browns have kicked a field goal first. The Giants have had a chance to tie them with a field goal or end the game with a touchdown. They've failed to do that, so they've got a lead of -3. They've lost the game, and so the game doesn't continue. The status after drive is no. Here, the Browns score a touchdown first, so the game is automatically finished. And so when I run different simulations of these, the overtime scores will update. And so the final score of the game can be calculated. Now, in cells J32 and K32, put the team names again, and then under that, starting in J33, I'm going to find the final score of the match if the scores in row 22 have been tied after regular time. The overtime calculations above will be performed, and then the final score here will be returned. So the formula for that is equals if J22 equals K22, the Giants score after regular time equals the Browns, then return an if error function, and in that if XLOOKUP, I'm looking up no within the lookup array P25 to P30, and then returning K25 to K30, the team. So 2 commas, then a third comma, then the search mode is going to be 1, first to last, close the bracket, equals J32, the Giants, then comma. I'm going to return an XLOOKUP function where again the lookup value is no in speech marks. I'm looking up no the text. The lookup array is the same thing, the status after drive, and the return array this time is the points accumulated from 025 to 030. 3 commas, search first to last, close the bracket. Now the value if false is going to be X lookup. The lookup value is, once again, in speech marks, no. Of course, the lookup array has got to be the same thing, P25 to P30. We're finding the first value of no in there. And the return array is going to be in 025 to 030. That's the points accumulated yet again. So it's the same one. But after we do that and then put the 3 commas in to indicate we're searching first to last, we're going to subtract an XLOOKUP function from that, where we're looking up no within P25 to P30 yet again. But this time the return array is going to be in column N, and that's the lead. So comma, N25 to N30, 3 commas to go to the search mode, which is going to be first to last. Close the bracket there, close the bracket again. Now the value if error is going to be an XLOOKUP function. The lookup value is J32. The Giants, in this case, the away side, we're looking them up in the J21 to K21 range and then returning the corresponding score in the row below. So the return array is J22 to K22. Close the bracket twice there, and then the value if false, well, if the game doesn't go to overtime, then the regular time score is the final score, which is J22. So close the bracket there. In this game, the Giants scored 6 points, the Browns 17, so there's no need to go to overtime. Now, I'm going to copy and paste the formula text into cell K33, and I've got to change every instance of J22 to K22 and vice versa, as well as J32 to K32. So I've got to switch columns J with K to switch it from the away side to the home side, and that's only for the cells without any referencing in them, without the dollar signs in front of either the row or column. And so I've done that now, and then I can give it a few simulations to test it out. And to make sure that the overtime function we just built is working, I'm going to fix the cells J22 and K22, the regular time simulated score at 10 apiece. And in this simulation, the Giants with the second drive of overtime score a touchdown to finish the game and win it themselves 16-10. And if I give it a few more simulations, in this one, the Browns win on the third drive of overtime with a touchdown themselves. So if I reverse the changes made to row 22 to put it back to the simulated regular time score, I've now got an overall simulation of an entire match, which includes regular time and overtime if needed. So what I'm going to do now to find the probabilities for all the betting markets, the money line, spread, and total points, I'm going to simulate the final result 5,000 times and get a distribution of the results. To do these simulations, lads, we've got to use a data table. So in cells B1 and C1, put the team names in row 32 below. Now, once you've altered the width a bit to cater for teams with longer names, you go into cell A2 and put the text trials. Below that, I'm going to spill 5,000 numbers representing 1 through to 5,000 trials using the sequence function. So sequence 5,000 will drop 5,000 numbers going down at row 5002. Now in cell B2, all I'm going to put is equals J33, the Giants' finishing score of the match. And for the Browns, same thing, K33, their final score as well. So that's a single game, 20-26 in the Browns' favor. I'm going to run that, including the overtime feature, 5,000 times now. So select cells A2 through to C 5002, which covers the 2 simulated ones and the below 5,000 trials. Go into the data tab above, go into what if analysis, select data table. In the data table, skip the row input cell. For the column input cell, it doesn't matter what you put, just put a cell outside of the data range you're simulating and you're not using. Press OK. It might take a few seconds to load, but once it does, you can scroll down and see 5,000 trials of the Giants vs Browns game played out, including the overtime feature if the game is tied. So in this first game, the Browns win 36-7. The next one, Giants 17-10. Closer one in the third, the Browns win 17-14, and that goes on for 5,000 trials. Now on the dashboard in cells K1 and K3, I can capture the amount of times the Giants win in the 5,000 trials and then divide by the number of trials, 5,000, to get a probability. So using the sum product function, put the double negative at the start, open a bracket, and then it's going to be simulations B3 to B5002, the scores the Giants get in all 5,000 simulations. That has to be greater than the simulations in C3 to C5002, the scores of the Browns. Now, if I close that twice with two brackets and press enter, it counts the number of instances where column B was greater than column C, that is the Giants scored more than the Browns. By dividing by 5,000, I can get the experimental probability, and that is the probability of Giants beating the Browns, the away side beating the home side. In this batch of 5,000 simulations, it was 21.9%, and you'll notice if I redo the 5,000 simulations, there's a bit of variance every time. If I did 1,000,000 simulations, this variance wouldn't be there. I'm doing 5,000 in this model so that we can get an accurate percentage with a small variance, but the model still runs well and doesn't freeze. So in order to get the win percentage for the home side in the Browns, I've got to copy and paste the formula text into cell K3, change the greater than sign to a less than sign, press enter, and then you get the probability for the home side, in this case the Browns winning, and they're the favorites in this matchup. You'll also notice that the sum of K1 and K3 isn't quite 100%. It's actually around 99.85% for most simulations, and that's because about 3% of games go into overtime in this model, and then 95% of those games are decided by the overtime function we've built. So that still leaves about 0.15% of simulations that are still tied up, and that's actually consistent with NFL games throughout the last 40 years. About 0.1 to 0.2% of them are still tied after overtime is played. Now lads, if you change the team in either cells D1 or D3, then not only does the expected score in cells I1 and I3 update, but also the win probability in columns K and L. The data table redoes all those 5,000 simulations according to the team selected, as well as the different parameters. Now in cells A6 to L6, merge and center the cells and put the heading markets. I'm also going to merge and center the cells A8 to H8, and then below that, put the headers spread, money line, and total points. Here we're going to work out the probabilities for each of those markets, and then put the titles from column A through to D in row 9, team, spread, probability, odds. Before we get the odds though, we need to select which odds we want. So in cells O1 to P2 and Q1 to R2, merge and center the cells. Selecting cell Q1, go into the data tab, data validation, allow a list, and I want to be able to choose from two types of odds. Firstly, American, comma, and also decimal odds, which is what we use in Australia and the UK. So press OK, and then, I can press decimal, but I suppose this is an NFL model, so after I change the text size to 24, we'll change it back to American odds. However, the formula we'll put in the odds column to change the probability for each market to fair odds will involve an if function that calculates the odds based on whether we select American or decimal odds in cell Q1. So for the team in cell A10 and 11, just put equals D1 and equals D3, the away side up top and the home side below that. Now for the spread, this is customizable. It's really whatever the bookmakers set it at. So here the Giants have about a 10.5 point expected disadvantage. So I'll give them a 10.5 point advantage, and the Browns in cell B11 a negative 10.5 point advantage or a 10.5 point disadvantage. Now to work out the probability that the Giants cover the spread, given that they've got a 10.5 point advantage, it's sum product, two negatives, open bracket, it's going to be their scores in cells B3 to B5002 plus B10, which was the spread for the Giants. So go into B10 in the dashboard worksheet, and then that's got to be greater than the Browns scores in cells C3 to C5002 in the simulations worksheet. So the Giants scores plus their spread has to be greater than the Browns scores. Close the bracket twice, divide by 5,000. When I press enter, the Browns have a 48.52% chance of beating the Browns, given that at the start of the game, they have a 10.5 point advantage. When I update those with a new batch of 5,000 simulations, of course, the variance there will change. Now, to update that formula for cell C11, just delete the plus B10, make the simulations in column B less than the simulations in column C, plus the spread in cell B11, the Browns spread there. And then for the sum of cells C10 and C11, that has to equal exactly 1. So reducing that to a percentage with 2 decimal places, I can get the probability of both the Giants and the Browns covering the spread. And now I can convert it to fair odds based off of that probability. So the formula for that is if Q1, absolute reference, so that we always refer to the cell of the selection between American or decimal odds in Q1, is equal to American odds, comma, return an if function that states if C10 is less than or equal to 0.5, then put the text plus space, then end with a speech mark, and use the round function with 3 opening brackets. The number is going to be 1 divided by C10, close the bracket, minus 1, close the bracket, multiplied by 100. Now, the number of digits we're rounding to is 0 because we're returning an integer or a whole number. Close the bracket, and if that's false, then return speech mark, minus sign, space, speech mark, and a negative round function where the number is negative 100 divided by 2 opening brackets, 1 divided by C10, close the bracket, subtract 1, close the bracket, and round that to 0 digits or a whole number. Close with 2 brackets, then return 1 divided by C10 if the odds selected aren't American, that is decimal odds. And so here for the Giants, I get plus 101 with a probability of 49.72%. When I paste that into cell D11, the odds update like that. So American odds that are minus means the event's more than 50% likely to occur, and vice versa with plus. And of course, lads, we can change the spread to see the differences in the implied probability and odds. So if I change the spread to 12.5, more in favor of the away side, the Giants, then the probability of them covering the spread increases to about 55%. Now for the money line, put the titles team, probability, and odds. And this is very quick because we've already done all these calculations. The teams are D1 and D3. The probabilities are K1 and K3, while the odds are just copied and pasted from cells D10 and D11 straight into C15 and C16. Now for the total points, there's 2 markets here after putting the text threshold in A19 and a target in cell B19. Either the total number of points in the game can be over 40.5 or it can be under. Now to find the probability that it's over 40.5 based on our 5,000 simulations of the Giants-Browns game, we can sum the simulations in cells B3 to B5002 with the cells next to it in simulations C3 to C5002. Now the sum product will grab every instance of the sum of B3 to B5002 and C3 to C5002, and how many times that's greater than the threshold in cell B19. So how many instances does the sum of the Giants score in a match as well as the Browns scores in a match result in their total points being over 40.5, and here that happens 42% of the time. For the under, just make sure it's less than B19 rather than greater. Pretty simple switch. Press enter on that, and it sort of varies around that 42% mark for this game, so pretty low scoring contest. Of course, we can copy and paste the odds in cells C15 and C16 into cell C21 so that we can get implied odds based on the probabilities calculated in column B. If I change this threshold in cell B19, then the over probability will increase because the number of points as the target has decreased, whereas if I increase the number of points for the target, then obviously the probability of the match going over that total has decreased. Now, if I change the teams in the match to say the 49ers and the Browns, not only does the total points markets update, but so does the money line, the spread, all of the probabilities update based on the simulations in the simulations worksheet. A reminder, you can also change the parameters in each of those markets. So I can change the spread for the 49ers to be a disadvantage for them, negative 4.5 points, while the Browns get 4.5 points here. If I change the home side to the Jaguars, then the probabilities will also update. So you can really change anything in here and the data table will simulate the outcomes. Now that the simulations are done, and for every matchup we can calculate the probability of the three main betting markets, I can add a feature to the model whereby I can input a range and the model will be able to bring in the fixtures yet to be played within that date range. So I'll merge and center the cells 08 and P8, put in my first date, Q8 and R8, put in my second date there, the 26th of September, and then below that I can create an upcoming fixtures table whereby the model can bring in the date, local time, away team, and home team between those two dates, so 22nd and 26th of September. Going into my fixtures data worksheet, which I created at the start of the video from the Power Query off of the website Pro Football Reference, I can put the text game status in the cell 02, and below that I can put the formula equals if the length using the len function of h3, close the bracket, is greater than 0, then return an if function which says that if the length of the cell I3 is greater than 0, then return the text P in speech marks. If not, return the text NP, meaning not played, in speech marks. Close a bracket, and if none of that's true, then just do 2 speech marks in a row, which returns nothing. And if, open bracket, C3 is greater than or equal to the first date in the date range. So if I go back into the dashboard worksheet, that's cell 08 in the dashboard worksheet, absolute reference that, then return if, open bracket, C3 is less than or equal to, and this time it's going to be dashboard Q8, so the highest date in the date range or the finishing date, and that's Q8 rather than 08. So that's over here. Put a $sign in front of both the row and column there. Return Y if that's true, indicating yes, it's in the range. If not, return nothing. So put 2 speech marks there. Close a bracket, comma, 2 speech marks, close a bracket, and press enter. So for this game is being played, but it's not in the date range, so it doesn't have NPY, which is what we need. Drag that formula down to round about cell 0500. I've done 0501 here, so drag it down past the date range. And that's what we're looking for. Games that haven't been played, indicated by NP, and then Y at the end, which is saying yes, it's in the date range. So now I'm going to create a table here starting in column S. I'm going to merge and center the cells S1 to W1, put the title NFL fixtures, and then for the columns, it's going to be date, time, away team, home team, and game status. So for the date in cell S3, it's going to be a very simple formula. If C3 equals 0, return nothing, which is 2 speech marks. If not, return C3. Now, you might get a number for the date. That's all right. Just change it to short date formatting. And then so I can drag that down to wherever I drag the game status in column O down to, I think it was about 501 rows down. So I can go back up now, and then the dates for each game should be filled out like this. For the time, same exact function, except I'm going to change the cells. Instead, it's if D3 equals 0, return nothing. If it's not equal to 0, it has a value, then return D3, what it is. Press enter on that, double click the bottom right hand corner of the cell to automatically fill that down to our final row here in this table, row 501. For the away side, same formula, equals if, open bracket, E3 equals 0, return nothing. If not, return E3. Drag that formula down to the bottom row too. And for the home team, it's going to be exactly the same as well. It's just if the home side is equal to 0, return nothing. If not, return the home side. if G3 is equal to 0, 2 speech marks, if not G3, close the bracket. And believe it or not, after we drag that down to row 501, the game status is even simpler. In cell W3, it's just equal to O3, and then drag that down to the final row of the table as well. Now that we've got the table completely filled out, I need to make it a table and then name that table. So select cells S2 to W501, go to Insert, and then Table. Obviously my table has headers, that's date through to game status. Press OK, and then the table formatting should appear like this. Now to name the table, a special table tab should appear, and for the table name, I'm going to name it NFL Fixtures. So I'll get rid of table 1 and instead put in NFL_fixtures. Once I do that, you can press enter, and then whenever you reference NFL_fixtures, it's referring to this table here from cells S2 to W501. Now I can go back into the dashboard worksheet, and in there I'll use a formula to pull in the relevant dates that correspond with the date range chosen in cells 08 and Q8. Now in O12, you're going to do the formula equals drop, and in the drop function is a filter function with the array NFL_fixtures, our table we just named. And in there, I want to include all values where the NFL_fixtures column game status, so in square brackets, game space status equals in speech marks NPY, not played, and yes in the date range, close the bracket, comma, 0, comma, and for the columns in the drop function, -1. Close the bracket there, press enter, and the array will spill all the games in the date range. I'll change column O to the short date format, and then it results in all these games being spilt, so I can just clearly see what game I want, put in the away team, and then put in the home team very quickly. Now I'm going to select cells O12 through to R1 million if you want, so that I can do some conditional formatting on the cells and make it look a bit nicer. So I'll go into conditional formatting, new formatting rule, the style will be classic, and then I'll use a formula to determine which cells to format. Firstly, I'll choose the format I want to do. So I want to customize format. I'll go into the fill section. The background color will be a light gray. And for the borders, I want a border along the top and then a border along the bottom. So I can customize that now. With the text appearing in the middle, I'll have a border surrounding that. Press OK, and so that's what it looks like there. And the formula for this is going to be equals if, open bracket, the length of $R12, close bracket, is greater than 0, then return an if function, which says that if the mod, open bracket, the mod function, the row function, open bracket, close bracket, comma, 2, close bracket, equals 0, return true, all in caps. If not, return false, close the bracket. If all that's false, return false. Close the bracket, press OK. And then when I scroll up, the formatting has been applied to my table in every second row, starting from row 12. And this will update when the date range changes as well. So if I extend the range to the 26th of October and more games fill the array, so will the conditional formatting. So lads, that's the end of building this model. I hope you enjoyed the video. Make sure you click the first link in the description below to be able to download this model. Once you build this model using the video and the Power Queries, or you download it from the Patreon, to update the data, what you've got to do is first select your teams in cells D1 and D3. The probabilities will update based on the expected points there, but you've got to make sure that you're using the most up-to-date stats in the 2023 NFL data and 2024 NFL data worksheets, along with the NFL standings and fixtures data worksheet. So go into the data tab, and to update the spreadsheet's connection with the internet, make sure you select the refresh all icon. This will reconnect the Power Queries with the internet and bring in the most up-to-date stats so that your model is as accurate as possible. Thanks for watching, lads.